Hello, and welcome to our sustainability and climate change awareness discussion. My name is Frank Catterman. I'm an electrical engineer, and I have with me my brother.
Well, my name is Matthew Catterman, and I'm a biosystems engineer. I guess I got interested in this sustainability project we're doing because I wrote a book. I did some research on biofuels. My book is called Biofuels Manufactured from Renewables Other Than Cornstarch. So I was interested in the sustainability that has to do with growing food crops for our use as biofuels.
Right, and so we're going to talk a little bit about global warming and climate change. Now, we're not trying to persuade people for or against, or I know everybody has their views on that out there, but what we're trying to do is make everybody aware of what's happening and some of the policies and legislation that will affect all of us, and whether you believe in global warming or not. Now, personally, myself, I'm not necessarily a global warming alarmist like a lot of people might be. Like there's a lot of people like, hey, we have to do something drastic right now because we're all going to die in 10 years. I'm not that far yet. I do think we need to be responsible, and we need to start thinking about how we can change for the better to make the Earth more habitable in the future. But I think that needs to be balanced with our freedoms and our livelihood as well. And so we need to think about that in a global sense and do it smartly. So that's sort of my position on it. Yours is?
Well, I come from an education background, so I've kind of been influenced by the classes I've been taking and the scientists that are in the field and reading. And so I kind of do believe in climate change. I believe it's real. So, and we'll talk more about that, but that's where I come from. But also the policies everyone should be aware of because it affects everybody's lives.
So regardless of what you believe in, it's going to be put upon you, and we're trying to make you aware of all these things that are coming up. So.
Yeah.
So let's talk about that. So Dr. Catterman, since you're the bioengineer, so we hear a lot of terms like global warming and climate change. Are they the same thing, or how would you define those two terms?
Well, global warming is just the rise in the surface temperature of the Earth. And that's just a simple definition of what global warming is. The climate changes or the weather patterns that change due to global warming. So, for example, when we see these weather events that are more drastic or they're more repeatable and consistent, but they're more extreme weather events. Like we'll see more intense rainfall or snow, or less rainfall in other areas, or maybe hurricanes, or longer or shorter seasons. Things like that you'll see with climate change. So
climate change is kind of a subset of global warming. Global warming is causing climate change, is what you're saying. We can see that there is climate change and warming. The Earth has warmed about 1.3, a little bit. It's less than 2 degrees in the last 100 years, right?
Yeah, it's just a little over 1 degree.
So that's a fact. I mean, that's the Earth surface temperatures are rising, right?
Mm-hmm.
And so I guess where the debate comes in is what's causing that. And we think it's probably greenhouse gases, right? Is that why don't you explain what a greenhouse gas is?
Yeah, greenhouse gases are chemicals or gases that are in the atmosphere, and what they do is that when thermal radiation comes and it interacts with it, what will happen is it will cause it to move and vibrate, and then it re-emits that radiation back towards Earth. So in effect, if you didn't have greenhouse gases, the radiation would come straight into the Earth, and some of it would be reflected and then go back out of the atmosphere. But with greenhouse gases, they intercept that thermal radiation, they interact with it, and they re-emit it back into the atmosphere, and so it kind of traps and keeps it in. So that's what greenhouse gases are.
So give us an example of what the most common greenhouse gas is.
Well, the most common greenhouse gas is carbon dioxide. So
okay.
That one makes up about 80% of all the greenhouse gases we have in the atmosphere. So that's why there's such a large emphasis on carbon dioxide.
Now, carbon dioxide is produced naturally, right? But it's also,
yes.
we make our own carbon dioxide too, right? So since the Earth produces its own, what's the big deal, right? Why are we so concerned about our production of greenhouse gases?
Well, almost everything you touch or you see is carbon-based. So when you have chemical reactions happen, a lot of it gets produced into carbon dioxide. It's just how it is.
All the waste we put out in the trash.
Because it's carbon, because we're breaking down carbon, we're all carbon-based things. All our materials are carbon. When we interact with that, it's going to produce carbon dioxide.
So like our vehicles, they
Yeah.
they produce carbon monoxide too, I guess. But is carbon monoxide a greenhouse gas too?
Yeah, carbon monoxide is a greenhouse gas. It's actually more dangerous than I think than carbon dioxide is. But
Now,
yeah,
oh, yeah.
so that's the big idea is that we have fossil fuels, and when we combust these, it makes carbon dioxide. So almost all our energy, whether we get it from electricity or vehicle fuel or heating fuel, stuff like that, or it's we combust it, and so then that produces the carbon dioxide. And that's the big concern. That's the big concern that we have about what's causing global warming. And in fact, they kind of feel that a lot of scientists are in agreement that the rise in surface temperature is correlated with the concentration of the greenhouse gases in the atmosphere. So say, for example, we have about 400 parts per million or a little above that, which is causing like a little over 1 degree temperature rise in surface temperature. When we have about 600 ppm, if that goes up to 600 parts per million or whatever, that may cause a 2 degree rise or something like that. I don't know the exact figures, but that's kind of what's involved with that.
Right. So, okay. So the Earth let's go back to what the Earth is doing. Okay, because the Earth produces its own carbon dioxide from the oceans, right? The air interfaces. There's land. When land produces some volcanoes, all these type of things happen on the Earth. But the Earth seems to take care of that itself, right? It's balanced on its own because it has these what we call carbon sinks, right? Like the trees and the plants and photosynthesis that absorbs the carbon back in, right? But we're adding to it, right? I guess we're not taking away some of that. We're not sinking our own production. Is that what the problem is?
Yeah, I mean, there's an overbalance of the amount of carbon dioxide that we have from emissions. So some of it, like you said, naturally is there's going to be carbon sources and carbon sinks, and the Earth has found a way to kind of balance that out. And when we produce more carbon dioxide, we produce a lot more, and just a lot more of it accumulates in the atmosphere.
When this accumulates in the atmosphere, you have all this carbon gas. Now they say that the Earth can handle a little more than it produces. It can handle absorbing a little more than it naturally produces. But are we at the point then where we're producing much more than what the Earth is extra can absorb at all? What its margin is? Do you think that this rise in temperature is caused by carbon emissions or greenhouse gases or not? It's still rising. The temperatures are still rising. Okay, no matter what's happening, we all know that. All right. So the fact that temperatures rise a little bit, and you mentioned that if it gets up to 2 degrees over the baseline, then we're getting kind of in trouble here, is what we're saying, right? So what kind of problems will we have as this keeps going up?
Okay, so we talked about what climate change is. We have these more intense storms. We have less rain in certain areas, seasonal changes. So these have certain effects to them. And so, for example, if we have seasonal changes where there's longer summers and shorter winters, but they're higher in temperature, this affects the plant life, and this affects our agriculture because the plants, and if you have a milder winter, the insects tend to survive longer, and
the pests
come and stuff like that. The plants will bloom earlier, so you'll get less quality of your crops when it happens.
Well, so if you get too much of a rapid change, they'll bloom earlier, then a frost comes and destroys them all.
Yeah, exactly.
Stuff, right? So, yeah. What about our water supplies, though? I mean, is that cause an effect on our fresh water supplies?
It does have to do with the snowpack or the snow melt that happens. So, from what they're saying from climate change, the snow melt happens earlier than it should because there's not as much snowpack, and that happens because in the shorter winters you have alternating periods of cold and then warm, and that kind of go back and forth. So when you do have an intense snowstorm, it melts right away, and so you don't have the snowpack that's generated in the mountains. So when the spring comes, not as much water flows from the mountains, or volume and the timing of it's off. So that's kind of the situation we face in Arizona right now. We're going to go through what's called a Tier 1 shortage. And we get a lot of our water from the Colorado River as CAP water. So the way that they establish these allocations is based on the elevation of Lake Mead. And so they said several years ago, they kind of came up with the drought contingency plans, and they said if the level of Lake Mead goes below 1075 meters or feet, I think it's 1075 feet, then they're going to do a shortage, cut back the allocation of water to states like Arizona. So we're facing this for the first time in Arizona. This will be our first time that we're going to go through it. And unfortunately, it affects agriculture. That's the one that's going to hit the most right now is agriculture. So,
Well, what other weather anomalies are happening because of climate change?
well, there's things called feedback effects. So a feedback effect means that you kind of get an amplification type of situation happening where it feeds on itself. So, for example, in deserts, what happens is you'll have higher global surface temperatures. Then that you'll have less overall evapotranspiration because there is a higher energy gradient that pulls out the water faster from the plants, and they start to dry out. You get less land cover. And when you get less land cover, you get less what they call latent heat of vaporization, which causes the change of the water vapor into water into water vapor. So you get this feedback effect that happens that causes less rainfall. And it just kind of amplifies itself. That's one. And the other one is with the global ice sheets, or the Arctic ice sheets. So the idea with that is that when you have hotter global temperatures, the ice will start to melt, and there'll be less reflection from the solar radiation. So the ice will melt more, and then so the sunlight will get absorbed more by the water in the land.
And it warms up the water. Right?
Warms up the water more, and it causes more ice to melt. So that's like another effect.
It's sort of like another loop, like you're talking about, because the ice itself reflects some of the radiant energy back out instead of absorbing it. So that's good. So the less ice, the less reflection. So the more it gets absorbed into the oceans, right? So
yeah, so that's exactly right. So that's how that works. And
where I differ, I guess, a little bit, is what's causing all this. I think that a little bit that man needs to be responsible. Yes, we all need to be as stewards of the earth need to be responsible. But I think that sometimes people like to take global warming and they like to twist it into making everybody so afraid and so scared. Oh my gosh, everything's going to be such a problem, and therefore you have to give up some of your freedoms and some of your mobility and some of your things you do and your lifestyle. You have to give up all these things. I want them to do something about it, right? So I think that's a little bit of an alarmist attitude. And so to me, I don't think that, I think what you're saying makes a lot of sense, but to me, it has yet to be proven that man is definitely the worst purveyor of all these things, that people are causing as much as they say we're causing. I think we're causing some of it. I think that we definitely need to do something about that. But we need to balance it with some rational thought and some honest discussion. Like they say, for instance, they say floods are happening more now. Hurricanes are happening more now because of global warming, right? Mm-hmm. Droughts are happening more now. Fires are happening more now. If you actually look at these stats over the last 100 years, you don't see a measurable increase in some of these things. In fact, some of these things actually are slightly going down over the last 100 years. So to me, that doesn't disprove climate change. I still think the Earth is warming, but for them to say every time that we have a really hot day, oh my gosh, see, it's because of global warming, or a hurricane comes, see, it's because of global warming. Well, that doesn't, if you look over the last 100 years, it doesn't mean that these things are happening any more than they were, 50 years or 100 years ago. So. But to me, that's what it is. It's a theory because we haven't ever experienced that before. So we can make a scientific extrapolation based on data the best we can. But
we can see if things like the jet stream are.
We'll talk about the jet stream.
The jet stream is weakening. We can see if that's maybe happening. We can see if a lot of polar ice is the sea level rise is happening. I mean, it's happened subtly right now. We know that since the time of pre-industrial levels, the sea level has risen about 6 or 8 inches. But they estimate if it gets to like 2, it's going to rise like several feet or meters. Right now, it's not happening, but that's because they want to keep it at 1.5 degrees so it doesn't become a problem. I think that's the biggest problem is actually the Arctic ice melt, or the ice sheet melts. Those are probably the biggest. That's probably the biggest problem, I think.
Yeah.
And the ocean acidification. That's another one. That's another effect that we need to be worried about. That environmentalists are worried about because, carbon dioxide gets absorbed by the ocean a lot more than it should, and it actually causes more of an acidic effect.
The Earth is a delicate situation. It's got its own balance, and I think we're maybe causing a little bit of the imbalance and all this. But again, for me, correlation doesn't necessarily mean causation. You have to now when you go back, let's talk about the ice core samples they take to figure out how much carbon and temperature was when they take these samples way down in the Earth, right? And so they figure out, okay, what are the natural cycles of the Earth? And they're talking about, hundreds of thousands of years of these temperature cycles, right, that have happened, over whatever the lifespan of the Earth, has been. And so when you look at that, we haven't even reached the max temperature that it was 100,000 years ago when it had its last peak, right? So, and the Earth did that on its own. We didn't cause any of that, right? So I guess what I'm saying is, we might think that we're causing all this, but maybe we're not. So that part I just don't know. I do think we need to be responsible, though.
I think a lot of it could have been caused by methane, and that's another point of concern, because methane, like carbon dioxide, is produced by a lot of different methods. It's produced, it's naturally in the ground, it's natural gas. Microbes produce, microbial life produces methane too. Mm-hmm. So a lot of that methane is locked up up in the polar region. So when that ice melts, a lot of it's going to come up. When they burn the forest down, or the land cover changes happen in the rainforest, the ground becomes more of a carbon source where microbes produce more methane. So there's a lot of concern about methane generation too. So that maybe something like that could have caused it's not just carbon dioxide. It's like methane that's.
And methane is worse than carbon dioxide also. So if this happens in natural cycles in the Earth and things, I guess we could say we're making it happen faster. Maybe that could be a theory, right? It's that the Earth's warming, but we're also making it warm faster than it should, or something. I don't know, because it seems to be up on an upward trend over the last, 10,000 years. So it's been on this slight upward trend. So when you look at a big picture, not the last 100 years, but the last,
Well, I said the sea level has risen about that high in the past when the temperature has been about 2 degrees. So if you repeat that again, you get to 2 degrees, you're going to have a sea level rise that's comparable to back when it was 2 degrees earlier in Earth's history. And that will that'll be a catastrophe for us,
right.
Here on Earth and stuff.
So that's, I guess, the whole point. Whether we're causing it or not, or whether we're the main cause of it or not, it's still, the Earth has these cycles, and they're very disastrous for whatever's living on the Earth,
Yeah.
So we could be the next victims of whatever this calamity might be if the Earth warms more than 2 degrees, right? So whether we're, the cause of it.
We could say, like, desertification is another example. That's kind of a catastrophe in itself. Much of our land is becoming more desert-like, and across the world.
Well, that's a problem.
And that's a man-made. A lot of that is man-made. So it's
right.
because of our choices that the land becomes more desert-like, and so.
Well, that's a double problem, because we're not only destroying the land and not having and all that carbon kind of gets in the air because we're taking it out and we're burning it. We're making materials out of all this forest, but yet then we don't have those carbon sinks anymore. We lose those, so it's sort of like a double adding, of this carbon effect. We're going to do a series of videos to kind of educate people on this subject, right? So we're going to, now that we kind of talk a little about what global warming is and why it's important, we're going to talk a lot about things about sustainability. You're big into sustainability and making sure that we're responsible with what we have, and so we'll talk about sustainability, what that is, what life cycle analysis is, what that means, some of the carbon markets and offsets and things. People talk about net zero and all that stuff. We'll talk about that. And we're going to talk about decarbonization, how we can actually do more than just, reducing it.
Yeah.
Good for now. So,
Yeah, no, that's good. Okay.
all right. So until next time, I'm Frank, and this is my brother Matt.